Priya?
Yes, sir.
Okay, and the screen is also visible.
Yes, sir.
Okay, so let us start. We have already seen the overview of mobile IP. Now, today we'll be seeing it in more detail that how the whole process is actually implemented. And up till today's lecture, it would be the syllabus for the uh, coming examination, midterm examination. Uh, I've already given you one assignment that was regarding 802.11. Another assignment I'll mail you today that would be regarding mobile IP. And it is suggested that please try to solve those questions that would be helpful in your midterm examination. Now, when we talk about mobile IP, as we have already discussed, that what are the basic steps in mobile IP is like there is a home network, there is a foreign network, and then there is another node, corresponding node, which is communicating with a mobile node, trying to communicate with the mobile node. Obviously, mobile node would be having IP address and everything which is related to its home network. Now, mobile node can change its point of connection and move from its home network to the foreign network. Means these two networks are having different network prefixes. So how this whole process is getting done, as we have discussed in the previous turn, when mobile node visits the foreign network, it would be registering with the foreign agent. Foreign agent will inform the home agent. I have taken the example of a person visiting different hotels in different cities. So all the letters would be forwarded to that person. And this home agent would be knowing the current location of the foreign agent. Corresponding node, not knowing anything, would always send data back to the mobile node. Now there would be a process of IP in IP tunneling, IP in IP tunneling. Here, foreign agent will provide this mobile node a care of address, which will be informed back to the home agent. Now, home agent will have outer IP address as care of address, and inner IP address would be the original address of mobile node. Using the outer IP address, packet will be routed to the foreign network, and then finally, at the tunnel endpoint, the outer header will be removed and packet will be transferred to the mobile node. In this way, mobile node is not required to change its IP address. So this was the uh, whole process of mobile IP in summary. Now, if mobile node changes another network, the whole process will begin again. We'll get another care of address and the whole process will begin. And in this way, the data transfer can be happening without changing the IP address of the mobile node. So there is one version of that instead of home agent doing the tunneling and transferring the packet, home agent can actually inform about the current location of mobile node to correspondent node directly, and correspondent node can transfer the data directly to the foreign network. But in this case, correspondent node will not be transparent about the mobile node location. Correspondent node will be able to know that where is the mobile node currently. Now, there is another problem that if mobile node changes another foreign network, another foreign network, then again the whole process will be there and correspondent node need to change the care of address of mobile node and to transfer the data directly to the next foreign network. So there are these two versions. One is indirect routing, where uh, correspondent home network or home agent does the tunneling, and there is direct routing, which I have just described. So if we see in the internal detail, there are three basic processes. One is agent discovery. Other is registration. And third is the delivery. Datagram delivery. There are these three processes, 1, 2, and 3. So we'll be discussing each of these processes one by one. Agent discovery, registration, and datagram delivery. So first of all, let's take agent discovery. Agent discovery. So what mobile IP standard has done, and these all things are described in RFC of mobile IP, and that RFC is uh, just a minute. The RFC is number of RFC is 3344. All these processes are described in RFC 3344. Now, what mobile IP is doing for agent discovery, there is already a router discovery. I've explained this thing in the previous course, computer networks, where ICMP router discovery method was there. ICMP router discovery. What is that ICMP router discovery? That router of any subnet, if there are how anybody can know who is the router of this particular network, who can throw the data back. So this router periodically sends the agent advertisement or the router advertisement that I am the router, I am the router, I am the router. What is that router discovery message? Just a minute, I'll be showing you that. This is the ICMP router discovery message. ICMP router discovery message, where there can be many routers in any network. Who is acting as a gateway, or how many routers are there, how many gateways are there to throw the data out of the network. This particular process is getting handled by ICMP router discovery. What is ICMP router discovery? The type is 9. Checksum is going to be there. How many number of addresses are getting advertised? uh, what is the size of, whether it is router discovery for IPv6 or IPv4. Here we are taking example of IPv4. This is 32 word, and the lifetime that this address, which is router address, is going to be valid for how much time. This is already there in ICMP router discovery. So mobile IP has done, what mobile IP has done has extended this router advertisement process. And this is known as mobility agent advertisement extension. And what is there in this? This is the extension where type is 16, length would be 6 is the fixed length, and number of care of addresses which are going to be advertised. Sequence number is necessary for knowing that how many time this particular thing has been done, count of advertisement message since agent was initialized. What is the lifetime of this agent advertisement? There are some flags, RB, HF, MGV. Right now, only two flags are important, which is H and F. When H flag is up, it means it is a home agent. When F flag is up, means it is a foreign agent. And then zero or more care of addresses. Now, this is, as I told you, H agent offers home agent services on this link. F agent offers foreign agent services on this link. And then number of care of addresses provided by this agent. So what is getting done? Whomsoever is uh, the taking responsibility of home agent, or foreign agent is generally a router. So it periodically sends the agent advertisement. Fine. Normally, if you see wherever there is a mobile IP implemented, a single router would be having interfaces for home agent and foreign agent. So at one interface, at one link, it would be acting as home agent. At another interface, it would be acting as a foreign agent. So home agent advertisement would be sent on this link and foreign agent advertisement will be sent on this link. And this periodically happens, agent advertisement. Now, just tell me one question. Why these advertisements are necessary? Why these periodic advertisements are necessary?
So there might be new mobiles in the area. They might not
Which
know
are
which.
arriving, or
Yes,
which are leaving.
yes, sir.
Now, obviously, these are ICMP messages which are encapsulated within IP messages. Fine. So, seeing the agent advertisement, mobile node can know what? Whether it is in home network or foreign network. Is it true?
Yes, sir.
How? Because mobile agent would be having its own IP address. So network prefix of mobile agent's IP address and network prefix of the advertisement, if they are same, it means mobile node is still in the home network. And when they are different, it means mobile node is in the foreign network. Only this thing is there regarding agent discovery. There are other flags and other things which we will take later after the mid-sem examination. So the first process which is getting done, that both mobile agent, both home agent and foreign agent keep on doing this periodic broadcast. How they do? Just a minute. How they do this thing? How they send the advertisement? They send the advertisement by setting TTL equal to 1 because this is for the local subnet only. And it is they use all system multicast address 224.0.0.1, or they will use a limited broadcast address for that subnet. So these agent keep on doing these, foreign agent or home agent keep on doing periodically these broadcast or all system multicast, setting TTL equal to 1 because this is for that local subnet only. Other thing I have already told, code is type is 16, length is 6 plus 4 and sequence number count of that. There are certain fields where right now only H and F are important. Agent lifetime is in seconds. That okay, for this time the agent is willing to accept the registration request. There are certain bit field we are not important right now. We'll be seeing that later. Now the next process is registration. Next process in mobile IP is registration. So the first is agent advertisement, which is using ICMP router discovery, which is already there, a mobility extension to that, and keep on doing this limited broadcast or the all system multi-class process to let everybody know that who is the agent right now for this subnet, whether it is a foreign agent or a home agent, whatever. Next step is registration. Now, after getting the advertisement, mobile node will be able to identify whether the node is in home network or foreign network, or it is returning to the home network. These are the three different things. It is in the home network, haven't visited anywhere, that is one case. It is currently in the foreign network, that is another case. It was in foreign network and now returning back to the home network. All these things require, in this case, no registration is needed. In this case, registration is needed. And in this case, third case, deregistration is needed. So you register to a foreign agent, and that information has to be sent back to home network that I'm currently in a foreign network and my care of address is this. How to get a care of address, Priya? If you remember in agent advertisement, if you remember in agent advertisement, these care of addresses are also advertised, 0 or more care of addresses. And mobile node can take these care of addresses who have visited to the foreign network. Now, what is getting done? What is getting done here? If a node is moving into a foreign network, it will listen to the agent advertisement and take one care of address, and then using foreign agent, it will register with the home agent. This is the process of registration. When mobile node comes back to its home network, you need to tell the home network that no, I'm back now. There is no point of care of address. I've got my own address. So it need to deregister itself. So I'm telling it again, when mobile node moves into foreign network, it will be able to listen to the agent advertisement. Listening to the agent advertisement, it will be knowing care of address because those agent advertisement are advertising those care of addresses also. Using this care of address, it will send a registration request towards its home agent via foreign agent. How this is done? Just see here. First process, first FA advertise the service. Mobile host requests for the service. FA relays this request to the home agent. Third process. HA can accept or deny the registration, and FA relays reply to the mobile host. After listening to the advertisement, because FA keep on advertising, foreign agent keep on advertising this agent advertisement with the care of addresses. Mobile host will request for the registration. Foreign agent will relay this request to the home agent. Home agent will do the registration or denies the registration and send the reply back to foreign agent, and foreign agent will relay the request to the mobile host. In this way, mobile host can be registered to the foreign agent. How it is done? It is done using UDP. It is done using UDP. A registration message which are encapsulated within UDP, which is encapsulated within IP. So this is regarding the registration. This is regarding the registration of mobile node. Details we'll be seeing later on. Details we'll be seeing later on. Don't worry about that. Uh, Only the details which are regarding with the these bit fields and other things, because there are advanced concept of mobile IP, which we'll be seeing after midsem. Right now, the important point is registration. How the registration is done? Registration is done listening to the agent advertisement, getting a care of address, and then relaying the registration request to the home network. Home network will update its database, accept the registration, and now mobile node is registered to the foreign agent. Obviously, in that particular in that time, you need to do the uh, routing changes and other things also, because home network now uh, assigns a care of address. So whenever a mobile node is addressed, the care of address is utilized for tunneling and things like that. That is going to be done. Any questions from anybody?
Yes.
So let me draw it again. Let me draw it again. The complete scenario. There is a there is a home network. In home network, there is a router which is home agent. There is a foreign network, and there is a router in foreign network which is foreign agent. There is a correspondent node. There is a mobile node of this network, mobile node, which currently is in the foreign network. Mobile node has moved from its home network to the foreign network. Right now, here is the mobile node. Now, this foreign agent, and in that case, the home agent also, we are periodically doing agent advertisement. When mobile node visits the foreign network, it will be able to listen to this, because these are one subnet broadcast, and mobile node will be able to listen to this agent advertisement. Seeing the agent advertisement source IP address, mobile node will be able to identify whether it is in home network or foreign network. As and when it identifies that it is in foreign network, mobile node will start the registration process. It's a UDP packet. So outermost is UDP. Then after that, the there is a mobile IP registration message, which is encapsulated by UDP, which is encapsulated by IP. And then this registration message will be forwarded to foreign agent. Foreign agent will forward this registration message to home agent. Home agent will register this mobile node as it has moved out, will do the changes in the database and the routing table, and then replies back that registration is complete, and now mobile node knows that it is registered to the foreign network. Now afterwards, if correspondent node sends any packet to mobile node, Home agent will intercept this packet, will create another packet where outer header would be care of address, inner header with the mobile node address and so on. And now this packet will be routed using the outer header towards the foreign network. At foreign agent, the tunnel is broken, tunnel outer header will be removed. If there is a co-located IP address, there are two type of care of address. One is the foreign agent provides one address, or it can be a co-located IP address where mobile node itself is having a another address for the visited network. So depending upon whether it is a co-located IP address or a foreign agent IP address, that would be the tunnel endpoint. The outer header would be removed and packet will be transferred to the mobile node. This is the complete process of mobile IP. So if you see the slides later on, there is a detailed example given with IP address and everything of registration, registration reply and everything. So this is a detailed example where foreign agent is a care of address. Fine. I've taken this example from the Perkins book. You can see how the packets are going to be forwarded, how the datagram delivery is there. Fine. So this example, I suggest you to see after the class. And if there are any problems, you can ask the question. So as I told you, three processes: agent discovery, registration, and third is the datagram delivery. Now let us see some spatial aspects. Now suppose this is a home subnet, home network, and there is a mobile node which was up till t equal to 5, it is in the home network. At t equal to 10, it has moved out. It has moved out towards a foreign network. When mobile node was there in this home network, the other nodes, say B, C, D, might have communicated with this mobile node, which was before up to t equal to 5 was there in the home network. प्रिय अब ध्यान से सुनना. When mobile node till t equal to 5 is there inside the home network, some different nodes of this network might be communicating with the mobile node. And these all different nodes are having ARP cache. Fine. So they might have contacted the mobile node, might have run the ARP process, address resolution protocol, might have got the MAC address of mobile node, and they have updated their cache with the MAC address of mobile node. Now mobile node has moved out. What is to be done?
When it moves out, the next time they try to communicate, the MAC address won't be reachable.
So,
So
so
it will.
our work is gone. Home network knows.
Yes, sir. It should be forwarded and updated to the source as well.
How? How to
Okay.
update ARP caches? Think over it.
Hmm.
I'm not talking about ARP because they would not be running ARP next if
Yes.
mobile node MAC address with its IP address is already there in the ARP cache? That's what I am asking. Think over
So
it.
it will have to, like, for the ARP cached update, it will have to fail once. Like, but we need to make sure that
The failing has got different reasons also.
yes, sir.
Fail once does not mean that it has moved away. Are you getting my point or not?
Yes, there
Think
there
over
is
it.
a specific message which it can respond back with, which will also tell it to invalidate the cache.
So there is a special ARP which is known as gratuitous ARP. I'm giving you 5 minutes to study about gratuitous ARP. And I'll be asking question. What is gratuitous ARP? Not in the context of mobile IP. As such, what is gratuitous ARP? The spelling is GRATUI, sorry, UITOUS, gratuitous. I'm giving you 5 minutes to study about this. What is gratuitous ARP? Yes, Priya, any answers?
Yes, sir. I think I got it. Like gratuitous ARP, we can simply say like it's a request without a reply or a reply without a request. So
Mm-hmm.
it's like when the net when a device just informs others like this is they will pass the same packet like a traditional ARP, but then it will ignore it as an ARP, but it will just update the cache based on the source
So
IP.
it can either send only request,
Yes, sir.
or it can either send only reply.
Yes,
So this gratuitous ARP is used, can be easily used in this case. When mobile node moves out, the home agent will send a gratuitous ARP. It is just a reply, a suo moto kind of reply, that the MAC address of this IP address, mobile node IP address is this. And what is that? The MAC address of that router. Got the point? Point?
yes, sir.
So when mobile node registers to a foreign agent, what will happen? The router or the home agent will send a gratuitous ARP reply telling that now the MAC address of this mobile node is actually the MAC address of that router interface through which that subnet is connected. Getting this reply, all the nodes will update their ARP caches. Got the point? So this is regarding how to update the ARP cache. Now the another question is, suppose any other node who wants to communicate with mobile node. Suppose there is a node E who in who previously have not communicated with mobile node, has just come up, is not having anything in ARP cache. ARP cache is empty. Now E wants to communicate with this mobile node. Obviously, E will run a ARP, but mobile node is not there. What will happen?
It will send a gratuitous ARP.
Hmm? Who will send the gratuitous ARP?
The home network.
So in that case, that is not known as gratuitous ARP. It is known as proxy ARP.
Oh, yes, yes.
If
That was also
if a home agent gets a ARP request which is trying to get the MAC address of mobile node, which mobile node which has already moved away. This is known to home agent because of registration. So home network or home router will also receive this ARP broadcast. Will see that okay, what is the IP address, whether this IP address has moved away. If that mobile node has moved away, then home network or home agent will send a reply as a proxy and will send its own MAC address to E, that the MAC address of this mobile node is this. So these two, proxy ARP and gratuitous ARP, are having the role here. Any questions? So if you see what we have covered up till now, the course is not very much for the mid-sem examination. I hope everybody can cover. We have seen wireless MAC. In wireless MAC, we have seen CTS and RTS to solve He then exposed terminal problem, wireless MAC. You can expect a question on this. Then we have seen distributed coordination function of 802.11. Remember that there are many nodes want to transfer on a single channel. We have seen CSMA, CA, binary exponential back off time, back off residual time. Fine. So carrier sense multiple access with collision avoidance. Distributed coordination function. We have explained in detail. You can expect a question on this. Then we have seen mobile IP. In mobile IP, we have three process: agent discovery, registration, and data transfer. And we use tunneling in that using the care of address. You can expect a question on this, one question on this. And there may be some general purpose questions also. There is a suggestion for you guys. The access point you people connect to your room, your personal access point. How these access points are working and how the data transfer is happening. I told you that example, that access point is running a DHCP, it is running a NAT also. So how this is working, this also you have to see. There might be some general knowledge question on this also. How our institute Wi-Fi work, the centralized controller, it will be covered in the after midsem. I've already given you assignment for wireless 802.11. Today I'll be loading some question, mailing you some question regarding mobile IP. Please go to the example of the slides, which are the slide which I have shown you. Slides are already uploaded. Let me see whether that slide is there or not. Let me see that. So you are requested to see those slides also. Now that slide is not there. I would be uploading the mobile IP version 2 slide. Let me upload it right now. So just do that example also from this slide, which I have just explained right now. Any questions?
No, sir.
So if there are no questions, we can stop here. And this would be the syllabus for your mid-semester examination. All the best.